Hi bio students, second video for the afternoon, in case you hadn't had enough of me today. I'm going to walk through the lab and some of the questions on your lab handout because I know that there was some confusion for some of you about that. And we'll talk about this again on Thursday, so if you don't end up watching this video, we will still end up discussing it, but as you are going through and trying to complete your lab handout, I wanted to give you a little bit of guidance for that, and then for the people who are absent, here's a alternative to doing said lab. It's less fun than doing it yourself, but at least you have a way of making it up. So in lab today, we're looking at diffusion. We have two solutions that we're going to separate with the membrane. The membrane that is being used is this dialysis tubing. It's clear, it is selectively permeable. It lets small things through the membrane, but it does not allow larger molecules. And so we're going to have our two solutions. We have a starch in water solution and we have an iodine in water solution. We are going to put one of the solutions inside of the membrane and one of them we will have outside of the membrane. All right, so in order to make this solute pocket, we have to open up our dialysis tubing. If you kind of pinch it and roll it around between your fingers, it opens up. I don't know if you can really see that on a video, but it opens up, it makes a tube. So if we want to put something in this, we need to close the other end of the tube. If we poured in a liquid right now, it would just go all the way through. So we use these clips called dialysis clips. We fold over one of the ends to close off that end, and then we clip it shut. We've just created the bottom of your baggie. Now we need to put our solution, our starch solution, into our little pocket that we've made. So we used a funnel, put it into the bag, or the dialysis tubing that we're making into a little bag. And then we're going to pour a little bit of this starch solution, starch and water, into the baggie. And then I'm going to do a little bit more. And then we are going to close our little baggie by folding it and clipping it on that end, just like we did on the other end. So we're going to fold this over and clip it shut. And I have created a little membrane-filled pocket of starch. In a second, I'm going to put this into my iodine solution. But I wanted to go through some of these questions. I am on the section that says what's in the bag, and then it has all of these questions about which one's hypotonic, which one's hypertonic. If those words are still a little confusing, I wanted to go through those questions with you and tell you what is being asked here. So in the bag, I have a starch solution. Your solute is the thing that is dissolved in the solvent. So the solute here is starch. Water is the solvent of life. In this class, water is basically always going to be the solvent. And so we have a solution with starch as a solute and water as a solvent. In the beaker, I have another solution. I have something else dissolved in a solvent. I have iodine that is dissolved in my solute of water. Solvent of water. Water is a solvent of life. I don't know if I just said that right. So in the beaker, the solute, the thing that is dissolved in the solvent, is iodine, and the solvent is water. So if I'm comparing these two things, with this beaker and this bag that I've just created and put starch in, one of them is much more concentrated for starch than the other one. It's this. I didn't put any starch in here. There is no starch in this beaker. So my starch is more concentrated inside of the dialysis bag. I'm trying to throw water on my computer. So number 3, starch is more concentrated in the bag. For iodine, it is more concentrated in the beaker. I don't have any iodine in here. I didn't put any. So if I'm comparing the inside of the membrane solution to what will become the outside of membrane solution when I put this in that beaker, my iodine is more concentrated in the beaker compared to what I put into the bag. When we're thinking about where are things going to move, we're going to be talking about the comparison of one side to the other. This is where our tonicity stuff comes in. So if I put this bag inside of my beaker of iodine, I now have a solution on the inside of the bag, my starch solution, that is separated from the solution on the outside of the bag, the iodine solution, by that thin dialysis tubing membrane. This is selectively permeable. Only some things are going to be able to pass through, and we're going to make some predictions about those things, what is going to pass through. And that has to do with the tonicity. So if I'm comparing the concentration of iodine in the beaker compared to inside of the bag, one of those has a higher iodine concentration than the other. That would be the hypertonic iodine solution. So the hypertonic iodine solution, where I have more iodine dissolved on that side of the membrane, is going to be in the beaker. It's hypertonic for iodine. It's higher on this side of the membrane than inside of the bag. In relation to starch, it's the opposite. I have higher starch concentration on the inside of the bag compared to in the beaker. I didn't put any starch directly into the solution in the beaker. I have a membrane between them. So my dialysis bag inside of that is hypertonic for starch. I have higher starch concentration than the other side in the beaker. The next two questions is just asking the opposite thing. Where do I have a lower concentration of that solute? So in relation to iodine, the side that is hypotonic, that has a lower solute concentration for that, would be where I didn't put any iodine. Inside of the bag is lower iodine concentration. So I have high iodine, low iodine in the bag. So hypotonic, the lower iodine concentration, will be inside of the bag. And for starch, the hypotonic, where I have less starch, will be in the beaker. I didn't put any iodine in here. It's all inside of the bag on that side of the membrane. Now we have some predictions. If the dialysis bag was only permeable to starch, which way would the starch move, into or out of the bag? We know that particles diffuse from high to low concentration. That's the definition of diffusion. If they're able to pass across the membrane and they're left to do that thing, they will go from where there's more of it, where it's more concentrated, to where it is less concentrated. So if it was permeable just to starch, the starch would move from where you have high concentration of starch inside the bag to outside of the bag. If it were only permeable to iodine, the iodine would move from where the iodine concentration was higher to where the iodine concentration was lower. So you would have iodine moving from the beaker, where you have the higher iodine solution concentration, to into the bag, where you have lower iodine solution concentration. The way that we're going to know what happened, what moved where, is because iodine is an indicator. It changes color in the presence of starch. When it comes in contact with complex carbohydrates, their chemical reaction happens and they bond and they turn a different color. The iodine changes from that brownish yellowish color to a blackish purple color if it is in contact with starch. So if either side of the membrane turns blackish purple, it means that iodine and starch are in that side of the membrane. They met up with each other. All right, so number 3 asks us, if the dialysis bag was only permeable to iodine, what color would you expect the solution in the bag to turn? We've already established that if it's permeable to iodine, iodine would move from the beaker into the bag. And so inside of the bag, we would have that indication that we had iodine that is now in contact with the starch. And we would have a color change. It would turn purplish, blackish. It's really more purple because it's not a very concentrated iodine solution. The more concentrated the iodine, the more dramatic the reaction is. If that were the case, and if it is only permeable to iodine, my starch is still trapped. It's not going to be able to move across the membrane. And so the solution in the beaker won't really change color. It might get a little bit more diluted looking. It might get a slightly lighter yellow color, but it's not changing to black purple. So the solution in the beaker is going to stay the same. If the dialysis bag was only permeable to starch, the iodine wouldn't be able to pass through. So starch could go from where there was high starch concentration to where there was low starch concentration, so from the bag out of the beaker. Where we would have iodine and starch meeting up would be out here. We would have a color change in the beaker where the iodine already was, and the starch made it out from the high starch concentration in the bag to the beaker, and we would have a color change. And the beaker solution, the second part of that question, number 4 here, would be changing color. We would have starch that escaped, come in contact with the iodine, and we would have the solution in the beaker changing to a purplish color. But we didn't get any iodine crossing the membrane. It is not permeable to iodine in this scenario, this hypothetical scenario. And so in our bag, we would have starch that left, but iodine wouldn't be able to go in. And so the in the bag would not have changed color. You don't have iodine and starch in contact. All right, the next part has you make a prediction. If you were not here for the lab, I'll give you a sec to think about the molecular structure of iodine, which is I2, 2 iodine atoms bonded together. and of starch. We know that's a complex carbohydrate. So make a prediction about what you think is going to happen. All right, I have another solution that's been sitting on the counter here for a while that I've allowed to go through this reaction so that we can kind of skip ahead and not just leave it for like 10 minutes. And what happened is this. When I pull out my little baggie, the iodine has gone into the bag. I have iodine that has permeated the membrane, has gone through this membrane, and is now coming in contact with starch. But my beaker solution is still yellow. It did not change color. So with that in mind, think about what had to move where in order to have that indication, that color change in the way that we just saw. That will help you with figuring out the post-experiment questions. I'm not going to answer those ones for you in this video. We'll talk about them on Thursday when I see you again. The one thing that I will tell you is number 7 asks, why is it not a good idea to store iodine in a plastic bag? This lab can also be done with plastic bags instead of dialysis tubing. So it's saying, if I were to use dialysis tubing as a storage mechanism or something similar to store iodine, why would that be a bad idea? So when it says plastic bag, it's talking about the dialysis tubing or something similar to it that would behave like it. All right, hopefully this was helpful and it answered some of the questions that you might have had, but we will talk more about it on Thursday.